Hello everyone. Um, we're back to the oscilloscope lab. This video is going to cover part 3 on your lab sheet. If you look at your lab procedure, part 3 is a repeat of part 2, except this time we're going to use a square wave. Okay, so let's get started. You can see here I have my signal generator hooked up to the oscilloscope with a square wave signal being displayed. And I have the AC voltmeter here attached to the signal output of the signal generator. And the procedure calls for measuring the RMS voltage with the AC voltmeter, which measures the average voltage over time. And we're going to simultaneously measure the peak voltage of the square wave. Okay, so we're going to take several readings, and then you'll make a graph. You fill out your data table, which is on the data sheet under part 3. Okay, and you'll make a graph of the RMS voltage as a function of the peak voltage. And from our lecture on lab notes, you'll know that the VRMS for a square wave is equal to the peak voltage. So your graph should have a slope of 1. Okay, so in other words, the VRMS is equal to 1 times the peak voltage. Okay, so I made a couple of changes from the last one. Well, namely, the way I set up the signal generator is I had to push the button for the square wave to get the square wave generated, and I increased the frequency to 10,000 hertz. Okay, so I have a 10,000 hertz signal there. Okay, on the generator. All right. So on the screen, I've adjusted the waveform to fit exactly across two. So I have two waveforms being displayed on the screen. So one complete waveform covers 5 squares. So if you look at the horizontal scale setting, I have this set at 2 microseconds. Okay, so the time scale per division on the is set for 20 microseconds per centimeter. And if I have 5 centimeters, the waveform, one complete waveform is in 5 centimeters. That makes 20 times 5, which would be 100 microseconds wide. So if you measure the frequency of that, the period would be 100 microseconds wide, and the frequency is 1 divided by that, which gives you 10,000 hertz. Okay, which is exactly what I have set on the generator. Okay, and I have set the amplitude of this wave to cover 2 squares. If you look at the ground signal, okay, if I put that switch on ground, okay, if I put that switch on ground right there, okay, that puts 0 volts on the oscilloscope. So I adjusted 0 volts to be on the center line. Okay, so now I'm going to turn the AC signal back on. So the peak of this square wave is 2 squares from the center line. We have 1, 2, and the volts per division is set here at 5 volts per square. Okay, so 2 times 5 is 10 volts. So the peak voltage is 10. Okay, the voltmeter is reading, it looks like 9.97, almost 10. So that's what we would expect it to read, somewhere close to 10. All right, so now I'm going to reduce the amplitude. I'm going to reduce the amplitude to 1 square. okay, to about half. Okay, so now you can see that the amplitude is 1 square high from the 0 mark, and I'm still on the 5 volts per centimeter square, so that means that my peak voltage is 5 volts. And the voltmeter is reading 5.29. Okay, a little high. All right, let's do this again. Now I'm going to change the volts per centimeter square to 1. Okay, so I've changed the volts per centimeter to 1 right there. Okay, and I'm going to reduce the amplitude to full scale. Okay, so I've got 4 squares now. Okay, I have four squares from the 0. Okay, 1, 2, 3, 4. Okay, 4 times 1 is 4 volts, and my voltmeter reads 4.17. The VRMS is 4.17. Okay, so now I'm going to reduce this voltage again down to 3 squares. Okay, 3 squares. I'm still at 1 volt per centimeter. Okay, and so therefore my peak voltage is 3 volts, and my voltmeter is reading 3.2. Okay, so something's out of calibration here slightly. So it could be the voltmeter, who knows, but we seem to have a consistent high voltage there. Okay, so now I'm going to reduce the peak voltage to 2 squares. Okay, so I got 2 squares from the 0. 1, 2. I'm still on the 1 volt per square scale. So that means the peak voltage is 2 volts, and the voltage RMS on the voltmeter is 2.16. All right, I'll do this one more time. I'm going to reduce this down to 1 square. There's 1 square. Okay, above the 0. I'm still on the 1 volt per square scale, and therefore I'm reading 1 volt peak, and the voltmeter reads 1 volt RMS. Okay, so here is the data for part 3. Okay, okay, there's my data table, so just copy that into your data table, and then you're going to graph the peak voltage on the horizontal scale and the RMS voltage on the vertical scale. And the slope of you should get a nice line with the slope of the line. It should be very close to 1. Okay, even though we seem to have a systematic error of 0.2 volts here on some of those readings. Okay, so that ends part 3. Okay, so when you're finished with this lab, you will hand in your data sheets, your graphs, and the answers to the questions. Okay, so if you have any questions on this lab, you can send me a course message or go on the discussion board. Okay, so I'm signing off.